Hi, I am Ayan Kumar Bania from the SketchX Lab, University of Surrey, and I shall be presenting our paper, More Photos Are All You Need, Semi-Supervised Learning for Fine-Grained Sketch-Based Image Retrieval. Fine-Grained Sketch-Based Image Retrieval, or FGSBIR, aims to retrieve a particular photo, based on a query sketch, at an intra-category basis. While recent FGSBIR works mostly relying on fully supervised triplet loss-based deep networks to yield substantial performance, collecting paired sketch annotation is costly, as every sketch needs to individually produced with respect to a specific photo due to instance-specific matching criteria. Consequently, current FGSBIR datasets still remain in thousands, while photo datasets are in millions. In this paper, we aim to answer the following question: how unlabeled photos could be used for instance-level retrieval problem like FGSBIR. We differ significantly to conventional semi-supervised classification. Other than learning pseudo-photo labels via a learnable classifier, our label for a photo is in the form of a visual sketch which needs to be generated rather than classified. The core of our design is a sequential photo-to-sketch generation model that outputs pseudo-sketches for unlabeled photos. Our utmost contribution is therefore a semi-supervised FGSBIR framework which treats photo-to-sketch generation and fine-grained retrieval as two conjugate problems, where a joint training procedure is devised for each module to mutually benefit from each other. Yet, naively cascading a generation module with retrieval would not work, since off-the-shelf photo-to-sketch generation models could sometimes lead to generation of unfaithful sketches that may not resemble their corresponding photos, especially when it comes to fine-grained visual features. This affects downstream retrieval model, resulting in performance degradation. Therefore, first, we propose a consistency loss by using a pre-trained FGSBIR model, as a weak teacher, to avoid overfitting to noisy synthetic data. Second, to quantify the quality of synthetic photo sketch pairs, we use a discriminator-guided instance weighting mechanism that specify a certainty score signifying the reliability of synthetic photo sketch pairs. Third, a joint learning framework based on reinforcement learning is proposed, which couples a sketch generation model with fine-grained sketch-based image retrieval. Ours is the first semi-supervised approach to solve the data scarcity problem in FGSBIR. A sequential photo-to-sketch generation model with 2D attention, modeling hierarchical abstract nature of sketch, is coupled with a retrieval model. The red and blue dotted lines represent the training path with labeled data and unlabeled data, respectively. At the retrieval side, discriminator DC is used as a certainty score to reweight the triplet loss for unlabeled data, and one pre-trained retrieval model from labeled data provides resistance against noisy synthetic photo sketch pairs through teacher distillation. FGSBIR model requires rasterized sketch images, and due to having the non-differentiable rasterization operation, we use policy gradient for feedback from retrieval to generation model. Our framework includes 4 important loss components to supervise the framework. A VAE-based photo-to-sketch generation loss is utilized that trains a model to generate the vectorized sketch representation by mimicking a human sketching style. For discriminative retrieval module, we use the state-of-the-art triplet loss-based network. The key objective is to improve retrieval performance using both labeled and unlabeled synthetic photo sketch pairs. Inspired by the generative adversarial network, where the sigmoid normalist output of discriminator shows the probability of being a real versus fake input sample, we use the discriminator's confidence to quantify the quality of synthetic photo sketch pairs. This objective is computed via a binary cross-entropy loss using label 1 for real pairs, and 0 for synthetic ones. Finally, to avoid overfitting to noisy synthetic photo sketch pairs, we introduce a consistency loss with respect to a pre-trained retrieval model as weak teacher. Note, we minimize the relative distance between the paired photo and sketch embeddings, which is a better knowledge to be distilled. Our joint training procedure mutually benefits both the photo-to-sketch generation and retrieval model. Apart from the VAE loss trained using labeled data, our photo-to-sketch generation also learns considering triplet loss and discriminator score as some critics. The retrieval model, on the other hand, uses both labeled data and synthetic photo sketch pairs from the photo-to-sketch model. We use top Q accuracy for retrieval, and for sketch generation, we consider recognition accuracy using pre-trained sketch classifier, top Q accuracy via a pre-trained FGSBIR model, and FID score on the generated synthetic sketches. A higher value of top Q accuracy and recognition, while a lower value for fit score, signify better sketch generation performance. We compare our both generative and retrieval module with several state-of-the-art competitors. Empirical evaluation suggests our proposed framework to perform better than its competitors on both retrieval and generation tasks. We also present some qualitative results on our photo-to-sketch generation process along with attention maps at progressive instances. An extensive ablation study is shown in the table that systematically removes each component, such as instance weighting, teacher regularization, attention, and joint training. The graphs show how a higher discriminator score corresponds to higher average ranking percentile, which verifies our use of discriminator-based certainty score. Finally, we observe our semi-supervised learning framework can lead to better performance than its supervised counterpart at varying low data regime.